So this week, guys, today and then Wednesday, today we're going to be kind of reviewing what we've talked about with probability and prediction so far. Um, Hopefully you've been following along if I haven't seen you in class during our live sessions. Then I hope you've been following along with the videos that we've been posting and the activities as well. Remember, anything that has an asterisk that looks like the little star is things that are for a grade. So you want to make sure, especially that you are checking and following along on our Google Classroom stream, as well as checking that online info sheet, which I can post here in a sec, just to make sure that you're all caught up. Okay, so today is a review of this unit, if we can call it that, of dealing with probability and using probability to predict likelihoods. Okay, and then Wednesday, so we've been talking about this for quite a while, so Wednesday will be our last day on it, so we'll close out with a brief setup review and then our test. So kind of seeing where we are at the end of this whole little unit on probability, and seeing how you guys do. So hopefully you'll do excellent. I have no doubt that you guys are capable of doing fantastic. Before, we've got a couple of review games that we're going to do today. But before we do that, I just kind of want to share and kind of jog our memory because it's been a little bit, right? So I'm going to share my screen. Make sure I got the right one up. Share. Okay, here we go. So I'm not sure if this is the right one. One sec, sorry. Go back a little further. Okay, this will work for now. So when we first, I think this was one of our first probability days, we were kind of talking about the difference between theoretical versus experimental probability. And we talked about, excuse me, how theoretical is something that you can try to picture. It's like a probability that you could determine without actually doing it. So, for example, rolling a die, we all know that a die is six-sided, usually anyway, right? And if we roll that die, then it's going to be either 1, 2, 3, 4, or 5, or 6 as a roll, something that's facing up. So we know the probabilities there, and there's a theoretical probability. There's a 1 in 6 chance of getting any of those numbers. Same thing with a coin, right? We know it's either going to be heads or tails, and things of that sort. Okay, so theoretical, you can picture it and you can say, okay, I can figure out the probability of this happening because it's kind of controlled, like a die or a coin, things like that. We could also have theoretical probability for other events. Like on this one here on the screen, we've got Nancy here has got a sock drawer full of socks, right? She has 4 red socks, 3 yellow socks, 1 green, 2 blue, 2 purple, 6 black. So she's got kind of a rainbow of socks, right? We talked about that one. And if she pulls out socks 50 times without looking and records her experiment, then we were talking about predicting the likelihood of the next try. So even if she pulls out socks 50 times without looking and records her results, it doesn't matter because each try is always going to be the same percentage because she's always putting them back and it's always starting out the same. So on the screen here, when it says probability of getting a black sock, it's just going to be 6 out of 18. 6 out of the total 18 socks is the likelihood of her drawing a black sock because she keeps putting it back, right? So that's predicting the likelihood on the next try using that theoretical probability, okay? And then we talked about kind of the probability based on the frequency of an event, okay? And that is basically another way of saying experimental probability. So if we had no idea how many socks she had, I mean, in this case, we do know, right? Oops. But if we didn't, then we would have to base it off of the results that we got. I don't know why it keeps doing that. Okay, so experimental probability is only based off of the results of the experiment. Okay, so if we, and again, it won't let me black this out for some reason. Let me click draw. Maybe that'll work. Okay, so if we didn't know this, if we just said she's got a sock full of rainbow drawers, and then after drawing 10 times, she gets like 2 reds. That's really big. Oops. She gets like 2 reds. She gets, 3 blues, something like that. And we have these sort of results. Then we could then take a fraction like we did here, like percentage of the probability of getting a red sock. Maybe a 4 out of 10 chance. Like maybe 4 times we got red socks out of 10 draws. It doesn't matter what the other ones are. We know that 4 out of 10, 4 out of the 10 times we drew a red sock. So that's the experimental probability would be 4 out of 10. Okay, so that's me changing this problem. But so long story short, experimental we said was based on what happened, right? Whereas theoretical probability is based off of the likelihood of it happening just in its existence. So like these socks that are already in the drawer that we know the count of, rolling 2 dice, flipping a coin, drawing a card out of a playing card deck, right? The playing card deck's not going to change. So we could have a theoretical probability. And one last thing, remember last week or the week before, we had you guys shoot paper baskets, right? Make a paper ball and shoot baskets into a like a little hoop. Pardon me, I don't know what's wrong with me. So in doing that, we were able to get an experimental probability of the likelihood of you guys making a basket, right? So if we had Ulysses or Cadence, right, and they are shooting paper baskets and they hit 7 out of 10 baskets, we go, okay. Well, based on that experiment, they have about a 7 out of 10 chance of making baskets, right? That's based off of the experimental probability. But we can't really have a theoretical probability for them because it's not like we're flipping a coin, right? It's not like there's only 2 options. There's a lot of factors. They might be shooting a basket really well that day. It might be shooting really poorly that day. So it just depends. But experimental is based off of the experiment, the results you have, and then theoretical is based off of what you start with. Okay, and so we talked about how you could predict things using that, and basically saying if you get, let's see if we have an example here. You get a percentage and you can multiply things. So for example, let's look at this last one here and then we'll do our review game. So look here, I'm highlighting. So let's say it says Megan checked her email for 30 days. She had 27 junk mail messages in that time. how many junk emails should Megan expect on the next 100 days? Okay, so we take our calculator, and all we really do is say 27 junk messages, right? Out of the 30 whole days, right? So 90% of the time, 90% of the days, she's getting junk mail. So then we say, okay, she's got, about or we could say 0.9 messages per day. And then you're going to say, okay, multiply by the number of days. Okay, so now we multiply it by how many are coming in the future. So that it should be about 90 emails. Okay, so in 100 days, she should get about 90 emails based off of the experiment. Okay, based off of the fact that in 30 days, she got 27 junk emails. So in 100 days, we should expect about 90. Okay. So using that percentage, multiplying by how many are coming in the future. All right, and I think that's all I've got pulled up on here. Let me just double check. Okay, deleted that one. All right. So, any comments or questions on that guy? Anything else you want us to kind of go over real quick? Okay. All right. If not, okay, then we'll go ahead and do our review game. And I'm going to try this out. We're going to try this thing that lets us break out into smaller groups. Okay. And if you remember from class, we did this once or twice. We did a thing called Quizlet Live. And that's kind of the one where you're working with the team, right? It's a team game. And you work with the team to try and select the correct answer and try to get all your questions correct in a row. And if if you get a question wrong, then it resets your team's score. And only one of the players in your team will have the correct answer. So it is, a team-based game. And so I'll put you guys it basically puts you in a private little Zoom chat kind of. So let's say Gabriel and Morgan and Abigail were in a group. Okay, then I would put you guys in a breakout group and you guys would work together and try to have your team win. Okay. So I don't think we're going to be doing it anytime this year, Gabriel. Probably going to be 9th grade or something. But you can always take it on your own too. All right, how are we going to team? So I'm going to go ahead and open up the game here. Teams. Okay. So I'm going to give you guys a code, and I want you guys to go to Quizlet.live to enter this code. So let me share this with you. Just screen share. Okay, so here's the code. Seven, 6, 1. 6, 3, 1. Okay, so you're gonna enter that code in at Quizlet.live right now, guys, and it will sort you guys into teams. Okay, and then I want you to, once it tells you what animal group you are, I want you guys to comment that in the group chat. Okay, so I can break you guys up. Good, I've got 5 so far. Good guys, keep joining. It's still joining. I just stopped sharing for a sec. See, we should have got someone else joining too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so we've got 8 out of 15 people so far. If you haven't head over to Quizlet.live so far, go ahead and do that. Okay, still got 8. That means we are waiting on how many more people? If we have 15, if you're already joined in, you can tell me how many people we're waiting on. Okay. I appreciate your honesty. That's good. All right. Good. And then 3 more, and then we're good. We have 14. We had 15, but it's 14. We need 3 more people, at least 1 more, so we can have even teams. Thank you, Unesi, Gabriel, Preston, Ulysses. Thanks, guys, for joining. Diego, Abby K, Jonathan, Candace, Cadence, Pablo. Excellent. Excellent work. And Anthony as well. Who? All right. Well, guess we'll go ahead and start. It's going to be a little bit weird with one team not having the same amount. Let's go ahead and get started. Okay. So I am going to screen share. All right. So here are our teams. And I'm going to go ahead and separate you guys into your 3 crews. So should be good. We got lions, penguins, and cheetahs. And now I'm going to try to break this up into 3 teams. Breakout rooms. 3 rooms. Manually. Okay. Gabriel. Preston. Ulysses. Diego. Okay. Oh no. Okay, tell me if this sends you guys into a separate room. So the lions should already be in a separate room. And then Yessie. Sorry. Abigail, Jonathan, Cadence. Boom. Got it. All right. Penguins is done. Cheetahs. Anthony. It's missing. Candace. Pablo. Okay. Briggs, I'm going to have you join in for Anthony for now. Okay. Let's go ahead and go with this. Open all rooms. There we go. Good job, Diego, Preston, Ulysses, Abigail, Jonathan. You guys found your way there. Briggs, Pablo. Good to know. Thank you. All right, so you guys are in your breakout room, so you guys can talk to each other. We are going to start. So I'll start the game, and then you guys can just use your screen, right? Your Quizlet screen and your chat to communicate with each other, okay? You can comment in this chat if it'll let you, if you have any questions. All right, may the best team win. Let's see who's got it. If you're not in a team, I'm going to go ahead and splice you guys up in case you guys can give some advice. Okay. Nice. Good job, Lions. You guys can talk in here to work together and try to figure it out. Okay? You guys feel free to unmute your mics while you're in here.
Oh.
Yep. Just like that. Good job, team 2. You guys feel free to unmute your mics, okay, while you're in the breakout room. There you guys can just collaborate and do your best. Thanks. Awesome. All right, team 3, you guys can unmute your mics while you're in this breakout room. That way you guys can just talk easily to work together, okay? Keep up the good work. Yes. Do you need help? So right now, because you were late there, Carl, it just makes it tricky with Quizlet Live because you can't join a team just yet. Okay. I will post here the code to type in, and then if we do a second round here, you can join in. Okay. But you feel free to talk to the other guys if they have a question and they can't figure it out. Nice. The cheetahs. All right, so let me pause the music. Ah. Okay. All right, excellent job. All right, so on your page, guys, each of your pages, it should show you what you missed and what you got correct. And so you can kind of glance at that real quick and see which ones you missed, how you can change that next time around, okay? All right, so I'm gonna go ahead, let's go ahead and try it one more time. This time I wanna make sure I get everyone in. We'll get different teams and see who can be the winner this time. Okay, so I'm gonna click, let me go back. It's very cheerful music. Hello.
What's up?
No, Raiden. All right, excellent work, guys. So we're gonna play one more time. See if we can have a tighter race, new teams, and most importantly, have everyone join in. I had about 3 or 4 that unfortunately joined late, and the only thing with Quizlet Live is it doesn't let you join late. So everybody, go to the link that's in the chat. Make sure that you join in.
Yeah.
Make sure you see your name
I
up
know,
on
we're doing
here
it
on the
again,
screen,
Cracker.
so that we can have everyone play.
Yeah. And you even got the answer wrong.
Gabriel, your microphone is on.
I know.
One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. Oh no, I'm missing people. Wait, let's try this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we're gonna have to. Sorry, real quick, guys. I'm gonna have to reset this link. Sorry, because I don't want you to have a ghost player. Okay. So one last time, sorry guys. I feel ya. Okay. Sorry guys. So join at this with this new code 495840. I had to do that because some people dropped out, and I want to make sure we got everyone in. Nice. You got 3 Abbies playing. That'd be pretty funny. Good. Jocelyn's first one in. Good job, Jocelyn. Excellent. And the quicker we hop in, guys, the more fun we can have. And we'll do maybe one more different type of game, and then we will be done for today. Good job, Ulysses. Good job, Gabriel. Good job. There we go. Good job. Aw, cute cat. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pause that music for a sec. We got 7 out of 12. That is a little over half. Let's get the rest of us in so we can all join in. Briggs, make sure to open maybe a new tab and then go to Quizlet.live. And then once that loads, then you type in 495840. Awesome. Quickly, guys, let's get at least. Oh, excellent. Let's get our last guy then. I think we had 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're missing one. We got Ulysses, Preston, Pablo, Carl, Inesi, I thought I saw. Yep. Okay. All right. Well, let's go ahead. Oh, you have 2 on here. Is that what you're saying? I see this. Which one are you on right now, Gabriel? Okay, you're just Gabriel, so I'll click the other one. Okay. All right. Well, let's go ahead and get started. Let's see our teams. Sea dragons, rhinos, and lions. All right. I'm gonna make our group here. Breakout groups.
Lions and tigers and bears, oh my.
All right. Jocelyn, Ulysses, Preston, and Gabriel. And then I've got Nisi, Pablo, Cadence. And last I've got Carl, Abigail, and Diego. Okay, and I'm gonna add Briggs to that last group, and the second group, I'm gonna add this number person. Hopefully you guys can contribute and answer any questions if they get stuck. All right, rooms are open. All participants have invited to be joined into breakout rooms. Have fun, guys. We'll start in about 5 seconds. 4, 3, 2, 1. Oh, Sea Dragons got the first point. Nice job. Good job, Sea Dragons. Once again, if you'd want, feel free to unmute your mics so you guys can collaborate and beat the rhinos and the lions. Good job, guys.
Yes. Beat the rhino.
Sir.
Good job. And once again, feel free to unmute your mics if you need to, so you guys can talk to each other about which is the correct answer. Okay, so good job. Remember, only one of the screens will have the correct answer for each question. All right. Good job. Remember, Lions, you guys can unmute your mics. So that way you guys can talk it and say if you think you have the correct answer, right? Because only one of the screens will have the correct answer.
Please, someone talk to me. There is only silence in this breakout room.
All right. Okay. Do you guys need any assistance over here?
Yes.
No.
No, you guys got it?
Except
You
Diego.
guys can do it. You guys did really well last time, so.
It didn't let me join the.
Yeah, there you go, Sea Dragons. Good job, Rhinos. You guys can do just as well. You guys did really well last time. Let me know if you need any help, okay?
Yes, not.
Excellent job, Sea Dragons. Keep up the good work.
Okay.
100 times.
Nope. 5.
Okay. All right, guys.
Session.
Abigail, turn your mic off.
I know.
All righty. So we're gonna go ahead and end there, guys. All of you guys did great. Maybe a little bit trickier that second time. But some of you guys were answering questions, trying things. Excellent job. Okay. So the last thing we're gonna do here, real quick. I know if you do have science, you'll have about 20 minutes from now, so it's still a little bit of time. We're gonna try to do this real quick. The answers should be pretty quick fire questions, so we can do this in a few minutes. But I'm going to go ahead and have you guys join this little Kahoot. And then we'll be done. And the only assignment, the only homework is just going to be caught up on all your IXLs if you're behind. Okay, because those, if they have an asterisk, that means they're for a grade. So I want to make sure that, more importantly than the grade, is that you know the material. Okay, and that'll help you be ready for the test on Wednesday. Okay, so all right, here is the link. Am I sharing my screen, hopefully? Okay. There we go. Okay, so you should be able to see this on my screen. Here is the code. So go ahead and open up a new tab. This time go to kahoot.it. Gabriel's already there. Good job, Gabriel. There is the code for kahoot.it. Good. Thanks, Jocelyn. Okay, and we'll say about 30 seconds to hop in. If you don't get in right away, that's okay. Because remember, Kahoot, you can join, even after the first question, you'll be able to join in and catch back up, okay? Good, guys. All right, we're gonna go ahead and start. And then, like I said, that same code that's in the chat, that's how you guys can join in, okay? All righty, here we go. You can make a simulation to make a prediction of experiments that would be hard to carry out. So can you make a simulation? Can you make like a fake version of something to make predictions of experiments? Kind of a weirdly worded question. Okay, the answer is true. You can make some sort of virtual simulation to do things that'd be hard to carry out, like maybe flying a spaceship to the moon. You could make some sort of simulation. All right, there's our first scores. We'll skip through some of those for now. All right, Ed read 12 books, 20 magazines, and 17 articles. What is the probability that Ed will next read a magazine? So you'd want to get the number of magazines, right, out of the number of things he read total, and that'll give you your percentage. Okay, all right. So you saw there should be about 41% chance. Okay, based on the experimental probability, right? Based on what he's read so far. All right. Next question. What is the experimental probability that Vanessa will roll an even number on a pair of dice? So that one's a little bit tricky, but you got a pair of dice.
It just says.
Oops, sorry. I jumped the gun a little bit on that. So 2 over 4 or 3 over 6 or 1 over 2, right? Those will all keep simplifying down to 1 over 2. So a probability of getting an even number, there's even numbers and odd numbers, right? On each. And they have the same probability. All right. What is the probability of not rolling a 5 die? Okay, so what's the probability of not getting a 5? So a 1, a 2, a 3, and a 4, and a 6 would count. Ooh, okay. So this is a theoretical probability, right? Because we didn't do the rolls, but we're just thinking about it. So if there's 6 sides, a 1 would work, a 2 would work, a 3 would work, a 4 would work. It can't be a 5, right? Because it's probably of not rolling a 5, and a 6 would work. So that's 1, 2, 3, 4, 5 numbers that would work out of a total of 6 numbers. So that's a 5 out of 6 chance, or 5 over 6. All right. Good job. Next question. 13 of 20 emails are junk emails. What is the experimental probability that the email is junk? So 13 out of 20 are junk emails. So what's the experimental probability that an email could be junk? Okay, we'll say about 10 seconds. 5, 4, 3, 2, 1. All right, 65%. Good job, guys. So 13, you just do 13 divided by 20, right? To get your percentage. And that's the probability that an email would be junk. All right. A compound event includes 2 or more simple events. I need this question. I know that might affect some of your streaks. You can make a guess on here if you need to. In 5, 4, 3, 2, 1. Sorry, that was my bad for not cutting that question out. All right, good job. It's got 2 different events going on. Good job, guys. All right. Amy has 5 shirts, 4 shirts, and 3 pairs of shoes. She can make 70 outfits from these choices. Once again, go ahead and just go with your best guess on this one. We'll go ahead and skip this one as well. All right. Sorry again about that one. Let's see. Okay. 8 cards go the hat, number 4 to 12. Pick the statement with the highest probability. Probability of getting a number smaller than 4, probability of getting a number bigger than 10. Getting an even number. Okay. All right, I may have to cut these last few because they're going into different territory. Yeah. I'm sorry, guys. Let's see where we're at here because I don't want to confuse this by going further. Over the next post. This one will actually work. All right. If there are beds 42 sells mattresses, they sold 3 twins, 6 double mattresses, 4 queens, and 2 kings. Give the probability that the next bed is a twin. So based off of that experimental probability, what's the probability that the next one will be a twin? So you want to take how many twins they've sold out of the total number of mattresses, right? To figure out the probability of getting a twin. Okay. 4, 3, 2, 1. All right. And I know we're cutting these short. So that would be 0.2. Okay. So what all you would do is say, okay, they sold 3 twin mattresses, right? Out of 1, 2, 3, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 divided by 15, it's a 20%. 20% of the mattresses they sold were twins. So that's the probability that the next one they would sell would be a twin. Okay, 20% or 0.2. All right, and last question. I served 23 colas out of a total of 111 drinks. Give the probability of cola as the next order. Okay, so this dog is selling us some Coca-Cola. Sold 23 out of a total of 111 drinks. Maybe there's some lemonades and stuff. Give the probability of the next order being a cola order. Okay, all right. And good job. If you said green, that is correct. 23 out of 111 colas was the experimental probability. So the probability of the next order being cola, we would say 23 divided by 111 to get our answer. All right. So here's our top 3. Nancy, Preston, and Diego. Excellent job, guys. And all of our participants, you guys did fantastic, okay? All right. Sorry that went so long. What we're going to do now, I'm just going to post this. Just check on Google Classroom, okay? It's the same, or if you already have it bookmarked, it's our information sheet for this math class. Make sure that you guys are caught up on all your assignments, okay? Especially the IXLs.